In this video, we're going to be solving rational equations such as these. Now, there's more than one method. For example, I would usually cross multiply these by multiplying n minus 1 times n plus 2 and setting that equal to n plus 3 times n minus 3 and going from there. That's what I usually would do. However, I'm going to solve this by using like denominators instead. The reason is that you can't always cross multiply. If there was another number here or another fraction, you know, like say if I had 1 over n or something, you couldn't cross multiply this. So I'm going to do this using a method that works on all problems. And that's the like denominator method. So I'm just going to first I'm going to space these out a little bit so I have room to work. So I have n plus 3 over n minus 1 equals n plus 2 over n minus 3. Alright, I'm going to write all of these in parentheses as well because we're going to view them as each one of them is a factor. Now, we need the denominators to be the same. So the right-hand denominator has an n minus 3, so we will put an n minus 3 in the left denominator. Now, anything I put in the bottom, I need to put in the top as well. Now, the left denominator has an n minus 1, so the right denominator will also need an n minus 1. And I will have to put the same thing in the numerator over here. Okay, so now I have like denominators. If the denominators are equal, then the numerators must also be equal. So I'm going to ignore the denominators. Because they're like denominators, I can ignore them. And I'm just going to set the numerators equal to each other. So I have n plus 3 times n minus 3 is equal to n plus 1 times n minus 1. Whoops, that's not what it is. Alright, it's n plus 2 times n minus 1. Alright, so I need to multiply this out by doing the double distributive property. N times n is n squared. N times negative 3 is negative 3n. Alright, when I multiply these, I get positive 3n and minus 9. Alright, I'm going to do the same thing over here, double distributive property. So n times n is n squared. N times negative 1 is minus n. 2 times n is 2n. 2 times negative 1 is negative 2. Okay, that's an n. I know it looks like a y, but it's really an n. Okay, combining like terms, I have n squared. These like terms just cancel out. So I have n squared minus 9 is equal to n squared. Negative n plus 2n is just plus 1n. And then I've got that minus 2 over there. So now I'm going to combine, well, I'm going to get everything on one side. So I'm going to subtract n squared from both sides. Alright, that's going to cancel out both of these n squareds. So that's going to give me negative 9 is equal to n minus 2. I'm just bringing these down. Alright, so to get the n by itself, all I need to do is add 2 to both sides. Okay, I'm running out of space, so I'm going to put it over here. But that's just negative 7. Alright, negative 7 is equal to n. And that is the final answer as long as that is not one of the excluded values. And looking back at the beginning, looking at the n minus 1, if I set that equal to 0 and solve, that tells me that n cannot equal positive 1. If I set n minus 3 equals to 0, that tells me n cannot equal positive 3. So these were my excluded values, 1 and 3. And this is not any of those, so we're okay. That's the solution. Okay, let's do number 8. Again, I could cross multiply, but instead I'm going to use the like denominator method. Okay, do I have enough space for this? I think I do. I'm going to make the denominators the same. So the right denominator has a 2. So I'm going to multiply by 2 in the numerator and the denominator. So now I have 2m and 2m squared. So somehow I need both of them to have m squared. Well, if I multiply this by m in the numerator and the denominator, then that makes m squared. So right now I have 2m squared and 2m squared. So I have like denominators. That means the numerators must be the same. So I can ignore the denominators and set the numerators equal to each other. So 2 times 1m is just 2m. And I never changed this fraction, so it's still m minus 34. So I would just subtract m from both sides, and that's going to give me the answer right away. 2m minus m is just m. So that's m is equal to negative 34. Okay, I should have written down my excluded values at the beginning, but I see I have m and then 2m squared. Both of those denominators tell me that m cannot equal 0. Alright, those were my excluded values. I'm getting m cannot equal 0 because I have just a plain m, so you can't have 0 in the denominator. But even you could think of the 2m squared, that can't equal 0 either. But if you divided both sides by 2, that gives you m squared. 0 divided by 2 is 0. Then technically you're taking the square root, and you still come up with m cannot equal 0, which is we already had. Alright, but just in case anybody was sitting there thinking, how is he getting that? And why isn't he doing anything with the 2m squared? I did. Alright, so that was it for number 8. Alright, okay, we have 4 more problems. Alright, I'm going to see if I can't do them a little faster. Okay, I think I will spread these apart a bit. So I have negative 3 over x plus 1 equals 4 over x minus 1. We need the denominators to be the same. I see that the right side has x minus 1, so I will multiply the left denominator by x minus 1. Got to do the same thing to the numerator. I see that the left denominator has x plus 1, so I need to multiply the right denominator by x plus 1 as well. Got to do the same thing to the numerator. Now that the denominators are the same, I can cancel them out and rewrite the equation just looking at the numerators. So now I've got, and I might as well go ahead and do the distributive property. So now I've got negative 3x plus 3 is equal to 4x plus 4. So to solve this, I want to get these x's together, so I think I will add 3x to both sides. So that's going to give me 3 is equal to 7x plus 4. And now I'm going to subtract that 4 from both sides. So that's going to give me 7x is equal to negative 1. Alright, running out of space. I'll do it over here. So I need to get x by itself, so I'm going to divide both sides by 7. And that's going to leave me with x equals negative 1/7. So this is probably the final answer. I need to check one little thing before I declare victory. The excluded values. By setting these denominators equal to 0 and solving, from the x plus 1, I know that x cannot equal negative 1. From the x minus 1, I get that x cannot equal positive 1. So these are my excluded values. But negative 1/7 is not excluded, so that is my final answer. All right. Let's do number 10. Now, I do see a common factor here. I'm trying to look and see if it doesn't look like that's going to cancel with anything, so I'm going to leave it alone. But you know, I'm always looking out for a common factor, and I see that that would be 2 and then x minus 4. But in this case, I don't see anything where it's going to cancel or anything like that. So for once, I'm going to leave the GCF alone. I'm going to space this out again. So I have 2x plus 1 over 3x plus 4. And that is equal to 2x minus 8 over 3x plus 8. And I'm going to use the like denominator method again. Again, I could cross multiply, which is what I would normally do. But this is a method that works for everything, and it gives me the same answer. So if you want to just learn one method, this is it, like denominators. Okay, so I'm going to give the left denominator a factor of 3x plus 8. Oops. Okay, to match the right denominator. I have to do that in the numerator and the denominator though. I'm going to give the right denominator a factor of 3x plus 4. Alright, notice that I couldn't just add 4 to make this an 8. That's a common mistake that kids will do, students will do. They will see that there's a 3x and a 3x, and they'll think, okay, all we need to do is make this an 8, so they'll want to just add 4 to the top and the bottom or something. You can only multiply. You can't go adding things. All you can do is multiply, because by multiplying by the same thing, we really are multiplying by 1. 3x plus 8 over 3x plus 8, that's 1. So we're not changing anything. When you add something to the numerator and the denominator, you are changing the value. If you don't believe me, look at the fraction 2/3. If you were to take that and add the same thing to the numerator and the denominator, so say if I added 4 to both of these. Okay, so now that would make 6/7. Alright, now does 2/3 equal 6/7? No, it just doesn't. Like 2/3, 6/7 doesn't somehow reduce down to 2/3. So adding something to the top and the bottom does not keep it the same. So we have to stick to multiplication. Okay, so like I said, this side needed a 3x plus 4 in the numerator and the denominator, of course. Once you have like denominators, you know the numerators must be the same, so you can just ignore the denominators and concentrate on setting the numerators equal to each other. Now I'm going to go ahead and double distribute as I go. So 2x times 3x is going to be 6x squared. 2x times 8 is 16x. And then I've got 1 times 3x is 3x. And 1 times 8 is 8. Okay, similarly on this side of the problem, alright, 2x times 3x is 6x squared. 2x times 4 is 8x. Negative 8 times 3x is negative 24x. And negative 8 times 4 is negative 32. Let's combine like terms, especially since we're running out of space. 16x plus 3x is 19x. And then I've got the plus 8. And over here I've got 6x squared. 8 minus 24 is going to be negative 16x. And I've got the minus 32. Okay, so now it's time to get everything on one side so we can see what we have. So the first thing I would do is I would subtract 6x squared from both sides. So minus 6x squared minus 6x squared. Okay, those cancel out. They were the same thing. So that just gives me 19x plus 8 is equal to negative 16x minus 32. Okay, now I will add 16x to both sides. Okay, so this is going to give me, what's this going to give me? If it were 20, it'd be 36, so it must be 35. X plus 8 is equal to negative 32. Alright, now I'm subtracting 8 from both sides. Okay, I'm running out of space fast. Let me see if I can just squeeze this in here. Subtracting 8 from both sides. So I have 35x is equal to negative 40. Okay, so if I divide both sides by 35, okay, that's going to give me the answer. Now let's go ahead and reduce this as we go. Both of these are obviously divisible by 5. 40 divided by 5 is 8. 35 divided by 5 is 7. So x equals negative 8 over 7. So that's the answer, as long as that was not one of my excluded values. So if I set this equal to 0 and solve, I'm going to get x cannot equal negative 4 over 3. I'm subtracting 4 divided by 3. If I set this equal to 0 and solve, I get x cannot equal negative 8 over 3. So these are my excluded values, my restrictions. And that's not either, this is not either one of those. So this is good. Okay, we still have 2 problems to do. We'll do them as fast as we can. This video is getting a little bit long. Okay, so I'm recopying a little bit. So I have 8 and I have x minus 1 over, now this would factor, of course, as x plus 2 times x minus 2. And you definitely want to factor so you can see what you have and what you need. Okay, over here I have x minus 2. So I need like denominators. That's the method that I'm going to use. So both sides, both denominators have an x minus 2. But the left denominator has an x plus 2. So I'm going to put that in the numerator and the denominator. Now that the denominators are the same, I can ignore the denominators Alright, so setting the numerators equal to each other, and I will go ahead and distribute right now. So I've got 8x minus 8 is equal to 4x plus 8. Yeah. Okay, so I want to get these x's together, so I'm going to subtract 4x from both sides. So that's going to give me 4x minus 8 is equal to 8. Then I would add 8 to both sides. Okay, so that's going to give me 4x is equal to 16. And then when I divide by 4 on both sides, then I get x is equal to 4. So this will be the answer as long as it is not one of our extraneous solutions. Alright, so this form is probably the best form to look at for the excluded values. So looking at the x plus 2 and the x minus 2, that tells us that x cannot equal negative 2 because of the x plus 2. And x cannot equal positive 2 because of the x minus 2. So the 4 is fine. Okay, so this will be the last problem. And again, I'm going to solve this using the method of like denominators. Okay, so look at this as being x over 1 for a minute. The left denominator has x plus 2. So that means I need x plus 2 in the right denominator. And of course I'm going to put the same thing in the numerator and the denominator. So that way I'm multiplying by 1 and I'm not really changing anything. Now that I have the denominators equal, that means the numerators must be equal. So 3 must, so I'm ignoring the denominator now. And I'm looking at 3 equals x times x plus 2. Now I'm going to go ahead and just do the distributive property. So that's x squared plus 2x. Alright, so the way to solve this would be to subtract 3 from both sides. So now I have 0 is equal to x squared plus 2x minus 3. Okay, so I'm going to factor this. So that's x times x to make x squared. 3 can only be 3 times 1. Now inner plus outer must equal the middle. Inner I have 3x, outer I have 1x. To get a middle of positive 2, I need a positive 3 and a negative 1. So there's my positive 3, there's my negative 1. Positive times a negative will make the negative 3 that I need, so this is good. Okay, so by the zero product property, I'm going to set each of these factors equal to 0 for my solutions. So x plus 3 equals 0, x minus 1 equals 0. Subtracting 3 gives me x equals negative 3. Adding 1 to both sides gives me x equals 1. Okay, let's just double check and make sure that neither of these are excluded values. I thought I had an eraser, but I'm just scribbling. Okay, so the excluded values, there's only one. So looking at the denominator, if I set x plus 2 equal to 0, that would tell me that x cannot equal negative 2. Alright, neither of these are excluded, so these are the solutions. And that was the last problem. I hope this video was helpful.